Do the matrices stuff. We'll start with this today. We're going to go, this is 4. There's only, I think, 5 sections in it. So we got 4-1, parts of 4-2, maybe a little bit more of 4-2, 4-3. I don't know. We'll probably be done with it around here, I'm guessing. I probably will either do a little quiz or a test. I haven't quite figured out as far as what I want to weight it as. It will be all non-calculator. I will not let you guys use your calculators on this one because there's buttons for everything. So what I might do is let you use the dummy calculators. That way if you forgot how to add 4 plus 3, instead of saying 12, you can actually type it in and get 7. Things like that. But so far it hasn't been that big of a deal. We've gotten through this rather quickly for these first 2 sections. We actually used the matrix not too long ago when you guys had that system of equations problem. We had the really large systems of equations. You use matrices more often than not to set up large systems of equations to solve multivariables multiple times. It's a very easy method to do it. Matrices are labeled by the rows and columns. You say that there are 2 rows and 3 columns. The rows go left and right, the columns are vertical. This would be considered, this capital letter A means matrix A, is 2 by 3. It's got 2 rows, 3 columns. Oops. So it's a 2 by 3 matrix is what they would call it. It's always rows and then columns. I'm trying to think what else there are real simple things here. Nice easy way to remember. Rows and columns, if you recall. I think you've seen this. You have to row your boat horizontally, because if you're rowing your boat vertically, you'd be dead. Because you went over the Niagara Falls.
Oh, yeah.
I mean, people go down the barrel and still be rowing.
Well, you could be. So this is.
People row down the barrel.
So you row, even though you're saying you're rowing down the stream, you're still rowing left and right. Merrily, merrily, merrily. Sorry, this was just me being silly.
How does it do that? How does it do that? How do you get like the actions to repeatedly and then just stop?
It's science. There is properties. Ooh.
It's just like on power.
Yeah.
I don't use power.
Oh,
Neither does Murphy.
Neither does Murphy, exactly.
It's a loss for you.
I said specifically to make it drive.
So I can do this. There's an option for me here under properties. I can do animation.
Oh, okay.
So.
Yeah, I just don't remember doing. I remember using Smart Notebook. I just don't remember doing that. That's what I was saying. Okay.
So anyway, don't write any of this down. I just want to show you what some of these things are called. A row matrix is a matrix made up of 1 row. Remember, it's called. We label them as rows and columns. So this dimension would be 1 by. Oops. This would be a 1 by 4 matrix. Okay. A column matrix is a matrix with 1 column. This one would be called a 2 by 1. It's got 2 rows and 1 column. And it's weird because it's just 2 numbers, even though they're going left and right. No, you'll see the terms every once in a while. I just wanted to show you what they look like. They're very easy to work with. A square matrix is a matrix that's got the same number of rows and columns. 2 by 2, 3 by 3, 4 by 4, and so on. Very, very common to have that. And then a 0 matrix is just a matrix of a bunch of zeros. There's a reason for that, and we'll talk about that when it comes up. It's not a big deal. When we're talking about matrices, though, in order to do some simple operations, the dimensions. Oops. The dimensions of the matrix matter. Okay. In order to do simple addition or subtraction, simple addition or subtraction. I'm not talking about multiplication. There's a different rule for that. The dimensions have to be the same. In order to add or subtract, I would say plus or minus. These have to be the same dimensions. And rows by column has to equal the same rows by column. those have to be the same. If they're not, you can't do it. Okay? Because all you're doing, if the rows and the columns are the same, is you're just matching up the entries within the matrix and adding them or subtracting them. It is ridiculously simple.
So just to clarify, like, if the first one looks like a 2.2, the second one would be a 2.2.
Correct. And if it isn't, it's not going to work. So for example, if I'm looking at this first one, oops. That's a 3 by 1, isn't it? The other one's a 3 by 1. Are they the same dimensions?
Yes.
Okay, what's 3 plus 1?
4.
What's negative 4 plus 0?
Negative 4.
What's 7 plus 3?
Yay.
There's your answer. Math.
It's really simple. It's really straightforward, but then I'll get locked in.
You're already ready for it, aren't you? Okay.
Dreams crush.
The second one, are they the same dimension?
Yes.
All you have to do is match up the entries.
What do you do with those answers? Like 4, negative 4.
That's what it is.
That's it.
That's it.
Wait, like, you do like the first one?
Wait, what? Yes, that's exactly it. What?
You do like 8 minus 2.
Yeah.
-7.
Yeah.
Okay, I don't know if you like combine
Nope.
it, and those things are gonna be.
What's 8 minus 2? Excuse me, 6. What's 3 minus negative 7? 10.
Okay.
The only thing you're going to screw up here is you're going to miss a sign. That's it. There you, yeah, that's it. And can I add the last one?
No.
Why not? You are right. We will sing our answers back and forth. Hooray! No, can't. They're not the same dimension, so your answer is no.
No, please. That's no answer every question. Quick. No. No.
You just add an extra column to everything, make it unequal.
Yes. The answer is no. No, there's no solution. You can't do it. They have to be the same dimension for addition. Like I said, though, multiplication, there's a different rule for multiplication. Totally, we'll talk about it in about 10 minutes. Same idea when it talks with scalar multiplication. You see this stuff a lot more. You don't see it. You'll start to see it more often later. If I'm looking at this, it just means 3 times everything inside the matrix. It's like one giant distributive property. That's all it is. A lot of times matrices are used with ordered pairs. And you use matrices with ordered pairs when you're in 2-dimensional space or 3-dimensional space. And you use that to move objects. You use it to move, they're called transformations. If you had ordered pairs of a triangle, 2, 3, 6, 4, and 1, 1. Those 3 ordered vertices are a triangle. You use a matrix to group them, and then you can use scalar multiplication to make it bigger, make it smaller. What?
Oh, in 7th grade we learned about like how to graph. We learned about scaling via multiple.
That's all this is. Seriously, this is it. Scalar using matrices is where that comes from. You use it in an upper level algebra when they start talking about vectors.
Is that the thing where it only goes one direction?
Yeah. So your answer here is just negative 6, 12, 0, and negative 21.
That was easy.
Yep. You could also do the following. We can solve matrix equations.
Oh my.
Do it on a Tuesday.
Now, what happens here is that you've got a whole bunch of junk on the left that has to equal the one on the right. What's that? Well, how would you solve this if you already knew the answer? How would you solve this?
I wouldn't.
What would you do?
Subtract the 1.
You still got to solve for x, don't you? You are given your answer, but you still got to find x. So what happens here? What's that? Oh,
So
okay.
that's like numbers before.
Oh, now with the number part though, I love, is that if you use this, when you start going through it, then when you multiply and add stuff together, it should equal. Now, does everybody agree that your answer is a 2 by 2?
Yes.
The stuff on the left is also a bunch of 2 by 2 stuff.
Yep.
Now, that means the following can happen. I can do my order of operations and take care of the addition in the middle. I get 3x plus 4, negative 1 plus 1, 8 plus negative 2, and 5 minus y, all times 2 still, correct?
Yeah.
That has to equal 26, 0, 12, and 8.
So you have to go by
Please take a lot of space.
No, you don't have to do that.
There's not one zero.
Oh yeah, I'm just showing you what's going on.
Don't you ask me this one?
Wait,
Watch what happens.
Wait, never mind. No, never mind. Yeah, I don't know. I don't know.
There's 4 entries here and 4 entries there.
Is it
So it's just there on the equation.
No. All I'm trying to show you guys here is that each of these entries, to make sure, in order for these two matrices to be equal, this has to equal this. What's 8 plus negative 2? What's 6 times 2? Are they equal? Okay. What's negative 1 plus 1? What's 2 times 0? So are these two the same? Which means all I have to do is take this, oops. Yeah, right. I said equal to 26.
Use your left hand again. That always
Yeah.
works.
And then I have to take the other one and set it equal to 8. All you have to do, really, is just pick the 2 parts that have variables and set it up. They're not going to trick you and set you up with matrices that don't work. Okay, they're not going to do that.
Can you solve for the variable and write the variables? We have to write them like a matrix.
No, because you just solve them for x. Now you're just solving for x. So divide both sides by 2, subtract 4, divide by 3. You have 3. And you're done. It looks a whole lot worse than what it really is going to be. Yes, ma'am? Sure? Let me show you another one here. What I want you to concentrate on when you're looking at something like this is that, do I need to write all of it out?
No.
No. What I'm getting at here is that you don't need to write the whole thing out when you're solving an equation like this. You're just trying to match up the entries to what they have to equal. That's it. That's all you're working on. So if I look at this next one, I have a variable in the top left. So that means I'm just going to use the top left of each of the 3 matrices. So I have 3x minus 4 has to equal what? You're squeaky today. Try another shoe. See, it's not squeaky. And then the other one, what are the ones you have to match up with? The bottom left. Everybody see that? Where's the variable? The variable's in the bottom left. So, negative 1 minus negative 7. Or excuse me, plus. So what's y? Negative 8. And what's x? -4.
Oh, it's negative, so.
And Clay, that's the thing that happens. You guys miss signs all the time. That's the only difficult part here is just being careful, taking your time looking, matching up your signs. That's it. This should be happy math.
Happy math is
Does it get any harder?
I know, but I try. I try my best. Just check this out.
We know that.
There you go. Yes, ma'am. No, what's up?
Are others always wrong?
What do you mean?
What?
By all means, use the easiest way possible. Okay. So let's multiply.
Yay!
Multiplying matrices, like I said, it has its own set of rules. And this is the one you have to pay really close attention to. In order to multiply two matrices together, in order to be able to multiply the two matrices together, you have a row by column matrix that's first, and then you have a row column matrix that's next. The number of columns in the first matrix has to equal the number of rows in the second. For example, if I have a 2 by 3 matrix here that has 2 rows, 3 columns. This one would be 3 by 4, for example. It would have 3 rows, 2 columns. What has to be the same here, the only thing that has to be the same is the number of columns in the first and the number of the rows in the second. So when you put the dimensions down, the two middle numbers have to be the same. What's that? Yeah, as long as the number of columns equals the number of rows, you're good.
That would be like a 3 by 1.
Yes, because now your answer, if you multiply these two together, would be a 2 by 4. It would result in a 2 by 4 matrix. And I have a really easy, nice trick to show you how to multiply matrices. Don't read your book. Okay? It's a nice trick. Okay? Let me show you another example, just matrix-wise. If you have 2 by 1 and a 2 by 1, those have the same dimensions, don't they? Can I multiply them together?
No.
Why?
Because
Because the columns don't match the rows.
Correct. The columns doesn't match the rows. Can't do it. I could add them, I could subtract them, but I cannot multiply them. So if this is a 7 by 9 and a 9 by 16, and I multiply them together,
Yeah.
what do you get?
7 by 16.
7 by 16. No, what I'm looking at here is the first matrix, these two numbers happen to be the same. So this matrix is just god-awful. And this one's even more awfuler. But as long as these two numbers are the same, I can multiply. I haven't gotten there yet. I just want to get you guys in the habit of seeing this first. Because now when I go to multiply them, I'm going to start with a very simple 2 by 2 matrix. I'm going to take a 2 by 2, I'm going to multiply it by another 2 by 2. I know that's going to work because a 2 by 2 and a 2 by 2, they have the same number of columns as they do rows.
And the answer is going to be a 2 by 2.
My answer is going to be a 2 by 2. Very good. What's that? That's just the dimensions of the answer. Okay? So this is a 2 by 2 matrix here, and I multiplied it by another 2 by 2 matrix. These two numbers are the same, so it's good, which means my answer is going to be a 2 by 2 matrix. Okay? But how you do it, we have to do a little bit of math.
Oh. Math is hard.
Now, when I first started doing and working with matrices, I honestly don't remember working on them when I was in high school. The first real time that we had to do a lot of it is when we took, it was an intermediate algebra course. I think it was 240 when I was in college. And I had a heck of a time with this. And this was after going through Calc 3 and DPQ and all that. For some odd reason, I could not grasp multiplication of matrices, and it was driving me crazy. I just could never figure it out. I would sit there and just get really, really mad because I couldn't follow the directions because it looks, the way that they teach it is such a rigid, nasty formula to do it, and I hated it. The yearbook still does kind of the same method. But my wife, she's my girlfriend at the time, she said, hey, do it like this. I was taught to do it this way, and it works. And she showed me one time, and I did a couple of it, and it just made sense ever since then. So this is the only way I ever do these matrices is because of the way my wife, a science teacher, taught me to multiply matrices, like 10 years ago, okay? This is really easy. And I you. So we know it's a 2 by 2 and a 2 by 2, right? The answer is going to be what dimension? Okay. How many columns are in a 2 by 2 matrix? 2. So what you do is you write down the first matrix twice. I need you to space it out. I want you to overspace it like I do right now until you get the idea of where everything's going to go. So write out the first matrix twice. 3, -1, 2, 0. 3, -1, 2, 0. And notice how I'm giving space. Okay. I worked my butt off for a B, like at 80%. So, yeah. It wasn't natural. It was not natural.
Then why are you a math?
Because I really liked it. I liked it, and how many times have I
good at it.
wait, how many times have I told you? Because I know I enjoy math because I know how I struggled at it. I know where you guys can screw up, so I try to give you guys the benefit of where you're gonna make mistakes because I did it. You guys are all better at it than I was. But I wasn't bad at it. I just had to work really hard at it. So here's the trick.
I don't get it.
Here's the trick. Always start in this method. You start at the top left of the second matrix. 1. Work your way down. 2. I'm all out of space. Go to the next column. -4. Work your way down. 1, 2. Go back up. -4, 1.
Don't overthink down and then across the same time.
You'll see. Between these, always. And then just duplicate those here. No, it's not. Well, that's the rule. Now what's happening is, notice what I'm creating. I'm creating 4 entries. I'm making a 2 by 2 matrix. By writing down that first matrix twice is creating the 2 columns. By filling them in twice is creating the 2 rows. So now what's 3 times 1? What's 2 times 2? What's 3 plus 4? -1 times 1. Not going to worry about it because there's 0. 3 times -4 plus 2. Then the bottom one is? There's your answer. To start the problem, you're going to write down the first matrix, the number of columns your answer will have. And then you just fill them through. What's that? Yes. You will always add between those values. Whether there's 2 of them, 3 of them, 4 of them, whatever, you're always adding between them.
What's the most you make?
By hand? I don't know yet. Yes, ma'am.
How, you're probably gonna show this, but I don't understand how this
Whoa,
is
wait a
explains
minute.
2 different
Dimensions.
dimensions.
Just wait. I'm gonna give you another 2 by 2, then I'll show you one, all right?
Okay.
Try this, let's do another one, but that's 2 by 2. All right? I know this is gonna work because it's a 2 by 2 and a 2 by 2. It's gonna work, okay? You know it's gonna work. I know that when it's, since the new matrix is gonna be 2 by 2, it has 2 columns, so how many times am I gonna write down the first matrix?
Twice.
Twice. A lady. You start with that. What's the top left entry? Next one is -5. Next one's 4. And the next one is 3. You just replicate it below. And now it's just math.
Spread out when it's not 2 by 2.
Forget it. So the top left is what? 16. Bottom left gets you
Wait, isn't it negative 16?
Wait, oh, bottom, okay.
Then I have -24 plus -6.
Wait, it's no, but it's -1 there. So it becomes 6.
Where?
There's a negative in front of the 6 too.
Yeah, -6 times -1
The 6.
is 6. So why isn't it -18?
Because it's a -2 times a -5, which is 10. 10 plus 6 is 16.
Well, I was putting the first of each.
Okay? And then the last one, you have 0 plus 9. Write down the first matrix twice, and then you start at the top left and work your way down. So it's -1, -5, 4, 3. And that's the biggest thing that people mess up. They'll miss a sign or they'll just flip-flop a value. Okay?
Let's try.
Let's change the dimensions. Okay.
Is there like formula to this? Like,
There is, and it's an awful way to say it, and I don't like to read it out because it doesn't make a bit of sense even to me to this day. All these years, it still makes absolutely no sense to me how it's written. I do not like it. That's why I'd say, you know it's going to be however many columns, write down the first matrix that many times, fill in the blanks. It works. There's no reason not to. It's the process by which you're taking the rows times columns. And you can get lost real quick by going across, working down. See how I went across here, then I multiplied down?
yeah, that's what I'm.
And that's what it is. It's row, down, row, down, row, down. That's what the process is, but you get lost in which ones you're doing every time, especially when your dimensions get messy.
That's what I was looking at, like, wouldn't the formula make that a little easy?
It does, small ones, yes. When you get to,
This one.
well, it's not even so much this is difficult, it's just when your dimensions start messing up, it's tough to know what you're gonna have for an answer. By doing it this way, I know what the dimensions are gonna be, because I'm forcing it to be that. It's a 3 by 2 and a 2 by 2. Can I multiply them? Yes. What will my answer be? So I know this is going to be a 3 by 2 when I'm done, which means how many columns will the new one have? 2. So how many times do I write down the first matrix? Twice. If. Remember, do these numbers match?
Yeah.
Well, then if those match, this is your answer. You just take those numbers. It's 3 rows, 2 columns. These are rows, rows, columns, rows, columns. The number of columns match the number of rows, yes. So your answer is 3 by 2. So 3 rows, 2 columns. It works every time. Every time. So if this was 13 by 2 and 2 by 2, I would have 13 by 2 when I'm done. Okay? How many columns in the new matrix when you're done? How many should there be? Since I know that there's going to be 2 columns when I'm done, I write this one down twice. You're probably starting to figure out how much you need to do it by now. Because what you're doing here is you're forcing yourself to make, bless you, you're forcing yourself to make, bless you, 2 columns. By doing it this way, you force yourself into your 2 columns right off the bat. So now let's fill in the blanks. Start at the top. 1, -2, 0, -1. And then all I have to do is replicate those values directly below it. And I'm just repeating the process. So now, like I was saying, you don't need hopefully you don't need a real calculator to do all of this. You just have -3 plus -6. -9. So we get -9, 3 plus 4, 7, 0 plus 2. The next one, notice how we have all those zeros. I'm not even going to bother with those. All I have to do is -3, 2, 1. Done. Yes, ma'am.
So if it was like, say the final matrix would be like a 3 by 3, then you're copying out 3 times?
Yep. Exactly. And I'm glad you asked.
Do we have to do those X and Y? Are there like gonna be X and Y we have to make where they're like equal to either side like we had earlier?
Probably eventually.
That means yes.
Not right off the not right off the bat.
Not right.
Do this one. Yes. It's a 3 by 3 times a 3 by 3, which means your answer is going to be
A 3 by
3 by 3.
Yay.
How does the calculator stuff work?
You press buttons. I showed you how to do that already. I'm not going to show you how to do it now.
No, it's like, no, not enough time.
3.
It took me all the time just to write it out loud. This morning. I was supposed to do it.
Oh, I don't know.
Oh, nuts.
And this is the reason why I'm not going to let you press buttons on your calculator.
Was that right? So far, no, I wasn't.
Oh,
Yeah. I just don't know how to add.
I screwed up.
I just don't know how to add. I'm confused. What's the what? Oh, that's the.
Yeah, why is the first one 3?
Why is it
Did you flip a value?
Why is the first one not 3?
What do you mean? The first one is 3.
But it says it's 5.
Where do you see?
No, the answer's right here.
The answer's at the very bottom.
This is the answer.
That's, oh, crap. Oh, this is
What I did here is I just put it in the calculator. I had to type all this in. 2 matrices multiplied together. hit enter and I get the answer.
Whoa.
What?
How is it so I screwed it up. I don't know what I did.
Try, you guys gotta try and do this without calculators.
30 plus
It's the whole thing, you gotta, it's the whole attention to detail.
Why is it?
What do you have?
Oh, you go down, you go across,
I just can't.
as you go across.
What is it wrong to set this one up?
That way, that's where I'm at.
That's what?
That was my first two.
Yeah.
6. Oh, I'm sorry, this is a negative, this is supposed to be negative 5. You wrote positive 5. It should be negative 5. And that's what'll get you. You just be negative and go all the way down. Okay. Wow.
Because it's negative.
Oh, I did it
Where?
Why do you have a 7 there?
It's negative.
That's not a 7. Guys, 7 is not the same as -4.
Thanks, Lincoln. Appreciate it, man.
42.
So -9 plus 4.
3 and 12.
Oh, there we go.
All your guys, not just, t-shirts.
Now I know.
Oh, it's negative 0, that's fine. You wrote it down.
So then you're 6 times 7.
Negative. That's all it was. That'll make it out. That'll clear it out. So, as you can see, it's the whole idea of watching how you do the write things down. Take your time as you're writing them out.
Get up. And I put it down.
Throw it.
I always get hit by the garbage. Like, it's not enough that I'm already garbage.
You're not garbage, Lily. We like you.
I'll have to throw garbage.
Garbage people don't sell garage doors for a living.
Colton, that's a really bad joke. You said she was,
They're all useless.
One little bless
bless you.
One thing I will hit about when you're talking to these problems here, 27 and 32, it's telling you to find, matrix A times matrix B, and then later on it might say what double AB is, or 3 times AC when you found AC earlier. Go back and forth and look at your answers that you already had. You might have already done some of the work. So, just shouldn't be so bad. So far, been pretty easy today. People have not been complaining. Don't do it. Which is good.
Yeah, Clay, you can have it. I can play because I got the.
I know, but that's, we know that's going to happen.